Welcome to another video for chemistry. In this video we're going to be discussing the periodic table. Two things that we'll discuss is the development of the periodic table and the structure of that periodic table. Okay, so let's start off with John Newlands. So we're going to first discuss the scientists that helped to develop the idea and the structure of the modern periodic table. It's the same table that you see in every science classroom on the planet. So he first noticed a repetition of characteristics in the elements. Every eighth element he noticed that the characteristics would repeat themselves. And he called this repetition the law of octaves. In fact, if you look at the name itself, periodic table, that's where it gets its name from. It's every period, every 8 elements, these periods repeat in the way they behave or in the types of reactions that they make. So again, this is called the law of octaves. Secondly, let's take a look at Lothar Mayer. He demonstrated a connection between the atomic mass and elements, and he arranged the elements in order of increasing atomic mass. Now, he wasn't the only one to do this. You'll notice that some of these other scientists, some of these characteristics that they discovered are actually just building off of the other characteristics that other scientists that preceded them discovered. So he wasn't the only one to notice that the elements were kept increasing in mass. Now, Dmitri Mendeleev, he took these ideas. He also noticed that the atomic mass would increase by element, but then he was able to organize them in an order in such a way that he was able to predict the existence of undiscovered elements. So in Dmitri's periodic table, which is the one that that we attribute the modern periodic table to, in his periodic table, he actually left blanks. There were blank spots that he predicted would be filled by elements that were not discovered yet. So really quite genius when you think about it. It's Dmitri Mendeleev. And then finally, Henry Mosely. Henry Mosely discovered the atoms contain unique numbers of protons called the atomic number. And he arranged these elements in order of increasing atomic number, which resulted in the periodic pattern of properties. So these scientists, like I mentioned before, they all had contributed different aspects to the periodic table, but when you combine all of these ideas, you end up with the modern periodic table. Dmitri Mendeleev being the most famous of them all in terms of the actual structure. So if you look at a periodic table in your classroom, you'll notice that it kind of looks like a castle, the wall of a castle. Well, that came from Dmitri Mendeleev. So let's take a closer look at each of the elements in the periodic table and how they're structured. Now, depending on the periodic table that you're looking at, you might have some variances, but for the most part, this is a pretty standard model. You'll notice that the atomic number is at the very top. You have your symbol, which is a capital letter. The first letter is always capital, and if there's a second letter, that's always going to be a lowercase letter. And then you're going to have the atomic mass, which is the grams per mole of this atom, and then the element name. Okay, and that's the typical structure of an element on the periodic table. The periodic table is also structured in 7 periods. The periods run horizontal, as you can see here, and then the rest of them as they go down the line. Okay, so there are 7 periods, and there are 18 groups. Okay, here I have pointed groups 1 through 8, 9 through 14, and then the rest 15 through 18. So there's 18 groups and 7 periods. Now, let's further break down the periodic table into groups. So due to the repetitive behaviors of elements, this is the law of octaves that we were discussing earlier that John Newlands discovered. These law of octaves pertain to what we call representative elements or main group elements. And these are the ones that I have highlighted here. So I have groups 1, 2, and then 13 through 18. Those are the 8 elements that keep repeating pattern by groups. Okay, so main group elements, representative elements. So our first group is called alkali metals. The second group of elements, family groups, is called alkaline earth metals. And again, each group in the periodic table, as far as the main groups are concerned, each of these groups has similar characteristics to the element below it. That's why they're called family groups. And then you have your halogens, and then your noble gases. And then you have your transitional metals in the middle. Okay, so your transitional metals are elements like titanium, which is used in hip replacements. And then you have your inner transitional metals. These inner transitional metals actually fit within the transitional metals. That's why they're called inner. And all of these are metals. Okay, so your metals share characteristics. They're usually solid at room temperature. There's only one metal on the periodic table that is a liquid at room temperature. That's mercury. They conduct heat and electricity very well. Some are better conductors than others. The more traditional metal used for conducting electricity is copper, but metals like gold and platinum are also used, and not often, but they are. There are some microphones, for example, that are wired in gold because of its ability to conduct electricity better than copper, but they're more expensive, obviously. And they also share the characteristics of being smooth and shiny. Now, then you have your metalloids. Metalloids share the characteristics of both metals and nonmetals. And you'll notice that they form a little stairwell starting at boron, and then it kind of proceeds down in the middle, in between your metals and nonmetals. Okay? So again, they share both characteristics. Okay, these metals are typically, or metalloids, these elements are typically used in computer parts, motherboards, and chips. And then you have your nonmetals. Okay? Like your neons, your gases. These are not shiny, unlike the metals. They're usually dull and brittle. They can be broken down into powders. This is phosphorus. Actually, let me back up a bit. That is sulfur right there. Sulfur has a yellowish color. And then you have phosphorus. Phosphorus you might be more familiar with in this form. Phosphorus is used in matches. So due to the repetitive behaviors of elements in your groups, now why? Why do these elements have repetitive behaviors? And that's because of their valence electrons. Period number 1, for example, like I have here, if you'll notice, they all have the same number of valence electrons, right? And those valence electrons are located in the s orbital. So that one valence electron that these have determine the behaviors that they're going to have with other elements. That's why they all share that behavior. That's why they're called a family group. Now, going down the line, these behaviors actually intensify as you go down. Okay, so group 1 elements all have one valence electron. That's why they all have similar behaviors. So let's look at another group, group number 5, your nitrogen groups. Okay, also same thing, and this is the same. This is true for each element in the main group elements. As you go down the line, you're going to notice that they all have the same valence electrons. So look at nitrogen, phosphorus, arsenic. They all have electrons on the s orbital and 3 in the p. So they all have the same electron configuration. Okay, each group does, with the exception of the transitional metals. Okay, so group 5 elements have 5 valence electrons. And this is true for all of my main group elements. Groups 1 through 18. And actually skipping groups 3 through 12. So it's 1, 2, and then 13 through 18. And again, this is what we attribute the repetitive behavior or the periodic behavior on the periodic table. This is what John Newland noticed. Okay, so each group has its own set of behaviors, family groups. And that does it for the periodic table. Okay, thanks for listening and good luck with your studying.